Morning, guys. We will have a look at the homework from Monday. This was the last thing in that second patterns chapter. Oh, actually, before I go any further, and just while I have you guys, I've just kind of changed your OneNotes a little bit. They're all the same. This is Cluxton's, but they're all the same. So see in chapters. So ignore that. In content library, when you click in, you have calculator, chapters, exam, formula tables book, homework journal, and reflections. Okay, so the only one I've changed is chapters, and all I've done is just made a couple of folders in here. It's just to tidy it up a bit. So that's sets, that's probability. In algebra, then I have the first patterns chapter, the second patterns chapter, and this is the new chapter today, chapter 15. And then in number systems, I have, there you go. So chapter 2 is natural numbers, chapter 3 is integers, chapter 6 is rational or fractions, and chapter 7 is decimals and percentages. Okay, so I've just put them into little folders just because the list was getting a bit long. Okay, so what we're working on now is in algebra, and it's this one here, chapter 15. Okay, so just so everybody has seen that. Right, so this is finishing off chapter 32. So let's have a look at this. A taxi driver charges a fixed minimum and then a fee per kilometre. The graph shows the cost of hiring the taxi journey for journeys between 0 and 6 kilometres. Use the graph to answer the following questions. Okay. Sorry, my pen is not working. Just give me a sec. Oh, okay, working again. Okay, so what type of pattern does this graph represent? So we've learned 4 types of patterns. We have learned linear, quadratic, cubic, and exponential. This one is a linear pattern. How do we know? We know because the graph is a straight line. Okay, so what type of pattern does this graph represent, and give a reason for your answer. So it is a linear pattern. And the reason we know it's a linear pattern is because the graph is a straight line. Okay, so part B, this was the one where you have to find the slope. And we know that the slope, hopefully you went back on yesterday's video or Monday's video even. So the slope is equal to rise over run. So I'm going to zoom in on my graph a little. Okay, and I'm going to make my triangle. Okay, so I'm going to start here, go across to there, and then we'll start here and go to there. Okay, so I made my triangle. So this one, the blue one, is the rise. And then the horizontal one at the bottom, why does this always happen when I'm doing a first year video? So the rise is in blue and the run is in black, which I have written in as well. Here it is. going to quit for a second. We go, yeah, full screen. Okay. So we'll do the rise first. So the rise starts here. Yeah. So we're going to figure out what that's starting at, we have to look this way. Sorry, I'm just going to undo that. That's supposed to be in blue. There you go. Okay. So we look that way and we see that the rise starts at 3. Follow the blue line all the way up to its absolute top, and the top of the blue line is there. So again, we look this way to figure out how high it goes, and you can see that that arrow is pointing at 15. So the rise starts at 3 and ends at 15. So we do 15 minus 3, which is 12. Okay, and if I go over here then, I can put 12 in for the rise. Okay, so now we're going to do the run. Okay, so the run starts here, my dot, okay, and when you're trying to figure out the run, we look down. Okay, so the run starts there at 0. Okay, follow the black line across and it ends here where I've put the dot in. So again, we look down and that is 6. So the run starts at 0 and ends at 6. So we do 6 minus 0 to get 6. And that's what the run is. So I'm going to go over here. And in place of the run, I'm going to put in 6. And then you use your calculator and you do 12 over 6. And you get 2. Okay, so I'm getting a slope of 2. So part C, what does the slope represent in this context? Okay, so what does that 2 mean in the context of the question? Okay, now I'm going to skip this for a moment because I think this becomes a bit clearer as we go further down. So I'm just going to skip it just for a sec and I'm going to go on to D. What is the y-intercept? So if you remember, the y-intercept, let's go with a highlighter. The y-intercept is where the graph intersects the y-axis. So there's the y-axis. Yeah? This in blue maybe. And here's the graph. Okay? So where does the luminous yellow line cross the luminous blue line is what we're being asked. And they cross there at 3. The y-intercept is 3. Okay, and again, the next one is asking us what does that mean in the context of this question. Again, I'm going to skip that for a moment, okay? I'm going to go down and do F. And I think then this should make it a bit clearer, hopefully. Okay, so when the distance is 0 kilometers, what's the charge? What just happened there? Okay, so draw, pen, green, insert. Okay, so here it's 0. Can you see the arrow? It's getting a bit kind of messy down here. Maybe I might delete some stuff. Okay, so I'll take some of this off. There you go. Okay, so now you can see what the green arrow is pointing. So when we've done, or this taxi has done 0 kilometers, how much is he charging? So we go to 0, we look up following that green line, and we figure out that he is charging €3 for no kilometers. Okay? Then we move over to 1 kilometer. So how much is he charging for 1 kilometer? So we need to go up until we meet the graph, and then we need to go across, and we can see that for 1 kilometer that's going to be a £5. Okay, I'll do another one with arrows, and hopefully after that you'll be okay. So 2 kilometers, we go up till we hit the graph, and then we go across. There you go. So that is €7 for 2 kilometers. For 3 kilometers, and then, oh, this one, go across. And we get €9, sorry, for 3 kilometers. So I'm assuming, hopefully now you can see the pattern. So each time this is going up by 2. So 4 kilometers should be 11, 5 kilometers should be 13, and 6 kilometers should be 15. Okay, and if you check that with your graph, I won't do them all, but 4 kilometers, what should we say? It should be 11. So we go up, hit the graph, go across, 11. Yeah, and so on for 5 and 6. Okay, so now I'm just going to take you back to part C. So part B asked us to find the slope, and we figured out that the slope was 2. And part C then said, what does the slope represent in the context of this question? Now, it is no coincidence that the slope is 2, and look what we get down here. 2 in between each term, okay? So, the slope is always equal to the common difference if you've done them right. Okay, so if you figure out the slope of the graph and you figure out the common difference, they should be the same. Okay, so what does this €2 mean in the context of this taxi driver? It means he is charging €2 for each kilometer traveled. That's what the 2 means, okay? So the slope and the common difference are the same. They both equal 2. So while the slope might be a little bit like, what the hell does that mean? I think when you look at it from the point of view of the common difference, it makes sense. So when this taxi has traveled 0 kilometers, it's going to cost you €3. At 1 kilometer, it's going to go up by 2, and it's now going to cost you €5. 2 kilometers is going to be another €2, so now you're at €7, and so on and so forth. So what does that 2, the slope, represent? Sorry, the slope represents how much he's charging per kilometer. Okay, next thing I asked you was, what is the y-intercept? And we figured out that the y-intercept was here, and it was 3. What does the y-intercept mean? Okay, again, okay, look at, can you see it there? There it is. Okay, so someone asked me in one of the chats yesterday, is the y-intercept always the first term? Yes, it is. Okay, the y-intercept okay, the y-intercept is always the same as the zero term. So here we have 0 kilometers traveled that cost €3. Do you remember we did, hang on, I definitely did an example. This one here, okay? What does the y-intercept represent? Look, the y-intercept was 8, and look, the 0 term was 8. Okay, so that very first term, the 0 term, the starting term, is always the y-intercept. Okay, so what does that 3 mean? So essentially, this taxi driver is going to charge you that €3 when you've travelled no distance. So €3 is charged when you haven't moved. Okay, remember we talked about this with the plumber, and they have like a call out fee. It's the same kind of thing with a taxi driver. If you get into a taxi, there's a fee that goes on the meter before it starts traveling. So the €3 charge when you haven't, it is a standard fee. Okay, so there's a fee charge just for getting into the car before the car has moved, and it's the same as the mechanic and the call out charge, or the plumber and the call out charge, or whatever. Okay, so that's what the y-intercept means. Now we did F. G. John hires a taxi to take him from his home to the airport, which is a distance of 4.5 kilometers. How much does the taxi driver charge John? So 4.5 kilometers. So here's my kilometers. Here's 4 and here's 5. So it's going to be halfway between them. So I'm going to zoom in again and see, can I figure out what halfway is? So how many boxes are there? 1, 2, 3, 4, 5. So I'm going to need to go right in the middle. Insert an arrow. I'm going to need to go right in the middle of the middle box. And that's 4.5. Okay? So we go up. Now I need to go up until I hit the graph. Make sure my arrow is straight about there. And then insert an arrow, go across from that point. Don't move. Okay. And that means it's going to cost John €12 to get to the airport. Okay, and the last one. Anne has hired the taxi to take her from her school to the nearest cinema. The taxi driver has charged Anne €21. What was the distance from Anne's school? So €21. So this is like the example. Our graph doesn't go to €21. So we're going to have to either extend the table or extend the graph. So, I like to extend the table, so that's what I'm going to do. So I have distance in kilometers, and I have higher charge in euro. Yeah? Okay, so this one, up here finished at 6 and 15. Yeah? So 7 kilometers is going to cost €17, isn't it? Yeah, so I made 6 to 7, and the 15 has to go up by 2, so that's where 17 came from. So then I have 8 and 19, then I have 9 and 21. There you go. So if Anne was charged €21, that means the cinema must have been 9 kilometers away. Okay? So there you are. That's the whole question. What are we on? Thursday the 18th of March or Friday the 19th of March. Okay, so that's the end of that chapter. We are going to continue with the new chapter, which is algebra. So I told you patterns was an introduction to algebra. It was the first time you've ever really used like letters in place of numbers and things like that. So yeah, this I'm just going to take you into full blown pure algebra. This is my absolute favorite maths to do. I love doing algebra. So I know it's different, but different doesn't necessarily mean that it's harder. Like it will initially be harder because you've never done it before, but give it a chance because it's actually really nice maths to do. There's lots of new terms, again, because it's new maths, it's new terms, but we'll do them slowly. And we are going to start today with what's called evaluating expressions. Now, we actually did a little bit of this when we did the second patterns chapter. Another word for evaluating expressions is substitution. The word evaluating is a fancy word for find the value of. Okay, that's what evaluate means. And an expression so basically an expression contains one or more algebraic terms. Okay, which sounds really fancy, but it's not. And I'm going to show you further down why it's not. Okay, so I'm going to give you an expression. So here's an expression. Okay, 6x plus 3y plus 2. Okay, now how many, I said an expression contains one or more algebraic terms. So how many terms does this have? It has 1, 2, 3 terms. Yeah? These terms here okay, they're referred to as variable terms. Okay, the reason they're variable is because they have an x and a y, and the x and the y could be any number. That means, so let's take the 6x for example, right? If we take the 6x, okay? Now, hopefully you remember this from patterns, but this is the same as 6 multiplied by x. Okay, so when a number and a letter are written beside each other, it's a multiplication. Okay, so let's say x is 2. That means 6x is 6 multiplied by 2, which is 12, right? But let's say I wanted x to be 4. Then 6x is 6 multiplied by 4, which is 24, okay? So depending on what your value of x is, your value of 6x is different or variable, okay? That's why we call them variable. Because they're dependent, because they have a letter, and that letter can stand for any number, depending on what the question decides, that makes them variable terms. Okay, they can have different answers depending on what the x is. Okay, or in this one, depending on what the y is. Okay, this one here though, that is just a 2. It has no letter, so it has no means of being changed. So it's referred to as a constant. Okay, something that is constant is unchanging. Yeah? So something that is constant is unchanging. Are we happy with that? That's just a couple of terms there. I think I have one more. I do. Okay. So might change this actually. The 6 and the 3. So when the number in front of a letter has a special name. It's called a coefficient. Okay, so terms, each bit is just a term. So 6x is the first term, 3y is the second term, and 2 is the third term. So there's 3 terms in this expression. 2 of the terms are variable because they have letters. Okay, and I explained down the bottom here, down here, how if you change what the letter is worth, then you change what the term is worth. And as a result, it is variable or changeable. Okay, the 2 does not have a letter, so that is unchangeable or unchanging, so that's a constant. And then when you have numbers and letters, the number in front of the letter has a special name. It's called a coefficient. Okay, so a couple of words there. You need to take all of that down. It's so important. And now I'm going to show you how to do this. Okay, so find the value of. Okay, I told you a minute ago, there's a fancy word for that. They chose not to use it here, but they could have. And the word is evaluate, okay? So they could say find the value of, or they could say evaluate. They mean the same thing, okay? So they want you to evaluate 2x minus 5. And for the first part, for A, x is going to be 4. Okay? So what we're going to do, if x is 4, then we're going to replace this x with a 4. So we get 2 bracket 4 minus 5. So what I have done is I have removed the x, and in its place I have put a 4. Okay? We know, or we should know, that in between this 2 and this x is an invisible multiply sign. So I have included my multiply sign down here, and I've done it using a bracket because remember, brackets mean multiply. Okay, so I didn't use the multiply sign, I used the bracket, but that's fine because brackets mean multiply. And before you ask, because I'd imagine you will, can you use a multiply sign? No. The reason you can't use it is because it's too similar to the x. So it gets confusing. Okay, so we have to use brackets. Okay, so 2 bracket 4 means 2 multiplied by 4, and 2 multiplied by 4 is 8. So that's this bit. Then we have minus 5, and 8 minus 5 is 3. So the value of this when x is 4 is 3. Yeah? So let's try B. So find the value of 2x minus 5. But this time they want x to be minus 3. So x is minus 3. So we're going to take that minus 3 and we're going to put it in here in place of x. So it becomes 2. Remember, there's a multiply sign here. So I'm going to show that with a bracket. Minus 3. And then I have my minus 5. So 2 multiplied by minus 3, the signs are different because remember this 2, if it has no sign, that means it's a plus. If the signs are different, that means it's minus. And 2 times 3 is 6. And then I still have my minus 5. Minus 6 minus 5. So if I, hang on. Smaller, sorry, hang on. This will make sense in a moment. Keep going. Okay, so I have a number line here, just in case you've forgotten how to do these, because this is a while ago. So remember that you start on this number, so there it is there. Yeah. The minus means I go left. Yeah. And then this tells you how many places to go left. So 1, 2, 3, 4, 5. So the answer is minus 11. Okay, and your calculator will do that for you too. I just wanted to remind you how to do it. Okay, so the value of this expression here, if you make x equal to minus 3, is minus 11. Yeah? So we have another one here. I'm not going to do all of them. I'm just going to do some of them. We'll do this one because it has a square and we haven't done squares yet. So D, we have a squared plus 2b minus c. Okay, and if you look up here, a is 4, b is minus 2, and c is minus 3. Okay, so I'm going to put my 4 in there, I'm going to put my minus 2 in there, and I'm going to put my minus 3 in there. Yeah? Okay, so a couple of things. Well, actually, no, one thing before we put the numbers in. If you have letters on their own, like, do I need to do it? No, I probably don't. We'll keep going. Okay, let's sub in. So I'm going to use a bracket. I'm going to put a 4 in place of my A, and I'm going to close a bracket and I'm going to square. Plus 2. And in place of my b, I'm going to put in a minus 2. Then I have minus, and in place of my c, I'm going to put in a minus 3. Okay, so the first one there, this one, 4 squared means 4 multiplied by 4. And 4 multiplied by 4 is 16. The next one, remember the brackets mean multiply. I'm multiplying a plus number by a minus number. So the signs are different. And do I need to write these rules down again? So same signs plus, and this is when multiplying or dividing. Okay, so when multiplying or dividing, if you have the same signs, you get a plus, and if you have different signs, you get a minus. Okay, so over here, I have different signs in the middle here. So that means I'm going to get a minus, and then 2 times 2 is 4. Now, look here, we have this like random minus. So it can't just be a minus, okay? That doesn't make any sense. So there is an invisible 1 here, which if that ever happens, you can add in. Okay, so now let's do this multiplication. So this signs are the same. That means it's a plus, and 1 by 3 is 3. And then this one you can do on a number line or in your calculator. So 16, where's my number line? Can I have enough for this 16? No. Will I extend it? We'll extend it. Insert a line. 8, 9, 10, 11, 12, 13, 14. I think about there should do it. So 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we are doing 16 minus 4 plus 3. Right, so we start on 16. Okay, then it's a minus 4, so we go left 4. So 1, 2, 3, 4. So now I'm on 12. And then plus 3, so we go right. So plus 3 is 1, 2, 3. So I finish on 15. Okay, so that last step, the adding and subtracting bit, has to be done either on a number line or on your calculator, or in your head, obviously. The previous step, the multiplying step, excuse me, is using your rules. What about the fraction? We do the fraction, and then we leave it at that. So 3a minus b over b plus c. Right, so let's get my colours going. So the a is going to be a 4. The b, this b and this b is going to be a minus 2. And then c is going to be minus 3. Okay, so we put them in. So 3 bracket 4 minus bracket minus 2. So put them in your bracket and then you won't mess up your signs. Minus 2 for b plus, and c is bracket minus 3. Yeah? Okay, so we'll start with this one. So neither of them have a sign, which means both of them are plus. So that means the signs are the same, which means your answer is plus, and 3 by 4 is 12. Now look here, we have this random minus with no number. So a sign always has a number, so we have an invisible 1. So when we multiply these two, the signs are the same, so it's plus again, and 1 by 2 is 2. Okay, now, so that first one there is just minus 2. There's nothing in front of it, there's no multiply, it's just minus 2, so I can just write down minus 2. Now, the second one, this bit. Oh, I don't know why I did that. Weird. That bit there. Okay, again, I have a plus with no number, so that's a 1. And look at the signs there, they're different, which means I get a minus, and 3 by 1 is 3. Okay, so the top line is 12 plus 2, which is 14. Sorry. The bottom line is minus 2 minus 3, so we do this on the number line. So minus 2 is here, and then minus 3 means go left 3. 1, 2, 3. So we get minus 5. So that is over minus 5. Now you can put that into your calculator, but it doesn't simplify, so I'd say just leave it alone. All right? So that's a few examples of how you evaluate or substitute. Okay? You'll be given an expression. Sometimes it has 2 terms, sometimes it might only be 1 term. Sometimes it might be fractions, all different types of things, okay? So we'll try a couple, not too many. I kind of want to mix though. Okay, so let's try a mix. We'll do. So let's do 2b. Let's do 3b. 4d. That's 1, 2, 3. 6a and 7a. Okay, so only do the ones that are circles. Don't do anything other than that. Okay, they give you the number at the top of the question for what is getting subbed in. So just make sure, use a bit of colour like I did or something to make sure that you don't get confused by which number is being subbed in where. Okay, and again, make sure you only do the ones that are circles. Alright, so that's your homework for the weekend. Enjoy. Let me know if you come across any issues.